Okay, we've got a problem here about a person floating freely in outer space under the influence of just a planet, an asteroid, and a star in terms of gravitational forces. So we're looking for the magnitude. First question is the magnitude of the net gravitational force acting on Iffy. And then in what direction is Iffy getting pulled? Assume 0 is the rightward direction, which is pretty standard. We always assume the right or the positive x-axis is where 0 degrees is, and then it swings from there. So some things to remember. Net gravitational force is gonna be what's the effect of these three forces on the individual. So to get that, you're going to add the vectors. So let's start by adding all three of the vectors together. And they're already given to us here in component form. So we're going to be adding 2, 4, 1, -1, -3, and 8, -2. Okay, so add the x component up, and you get 9. And add the y components up, and you get -1. So I'm going to actually color this red and put it on the plane. And I'm going to call it, I think I'm just going to call it G for net gravitational force, vector G. Okay. So in other words, with these, if it was just the asteroid acting on this person, that would be the direction and the magnitude it would pull them. Okay. If it was just the star, it'd be the green one. But it's not just that, it's all three of them, including this planet here. So you combine all those with addition, and what you get, so 9, -1, 2, 3, 4, 5, 6, 7, 8. So 9 is way out here, and then -1, of course, down here. So this is the net gravitational force. Another way to think about this is visually. If you were to add the three vectors visually, you're just kind of doing the heads to tails method. So putting, the green vector here, oopsies, my eraser there, the green vector, and if we were to just set that heads to tails with the asteroid vector, and then do the same thing for the planet vector in blue. Okay, move that over. See where that heads to tails method gets you. So that's the net gravitational. That's one way to think about it. So this, if he doesn't push on the thruster button at all to counteract this, they are going to land way out here as a result of that net gravitational force of all three of those bodies. Okay, so we need to know the magnitude of that. So if I call that G, we're just looking for the magnitude of G vector, which was the sum of those other three. And I'll set this up, but I'm going to do it on a calculator off screen here. Actually, these numbers are not big, so what do we get? 81 plus 1, so radical 82. Our instructions are to round to the nearest tenth. So I'm assuming this is going to be 9.0 because I just don't think that's enough of a... Well, no, it does round to 9.1. It's 9.055 something. So 9.1 is what we'll settle on for the magnitude. Okay. And then the second question is, in what direction is Iffy getting pulled? Assume 0 is the rightward direction. And they give us a little more indication here too. They say your answer should be between 0 and 2 pi. In other words, there's two things there. That's kind of a loaded statement. The first one is it's in radians. Don't forget that. The second one is the angle must be positive. So I say that because if you look at the angle that first kind of meets your eye, it's this negative angle below 0 in the fourth quadrant. But what we have to do is actually get to the fourth quadrant the other way. we want to go all the way around and find out what that angle is. Okay? So in what direction is Iffy getting pulled? It's going to be something close to 2 pi. Remember, pi is exactly the same as 180 degrees, and this isn't 0 degrees, it's 0 radians, and that's the same as 360 degrees is the same as 2 pi. So it's almost a full rotation. So we're looking for a big angle. So we're going to set up and find our direction angle the same way we always have, with theta equals tan inverse of the component form y value and divided by x value. So here that turns into tan inverse of -1 over 9. So again, actually on a calculator, you're going to want to make sure your mode is set to radians. That'll keep you out of the weeds here. Make sure you're in radians, and we will get, I have to go about, I'm going to have to round this out, I'm pretty sure. So set my mode. I'm on an off-screen calculator again here, sorry about that. And we get tan inverse of -1 divided by 9 is, yep, it's going to give us this -0.11. They're saying to round to nearest tenth, so I probably don't need that hundredths. I'll just say -0.1 radians. And so I'm telling you that's this little angle here. But what we want to do is add 2 pi, I almost said 360. Add 2 pi to get that to be positive. And so I'm going to add 2 pi. And now we get the actual angle we're interested in. On the calculator, you go -0.1 plus 2 pi, and use the pi button if you have one. And that'll give you 6.2 when you round it off, 6.2. Okay? So it's very close to a full rotation, but that is the direction that Iffy's getting pulled, 6.2 radians.